Well, first of all, I'd like to thank Jean for his wonderful presentation. He's in the same industry as we are. He's not. It's no coincidence if we share a lot of the same ideas, and you'll see during my presentation there are some points that overlap, but presented perhaps from a point of view of a small local service company with a more local market than IntelliBeat. So I hope you'll be able to identify with it and see what can be of use to you in this industry. So there'll be 8 points of the presentation. I'll speak about the objectives, what is my purpose for being here today. I'll talk about our Quebec industry, industry at a glance, see what the obstacles are, why we have a hard time settling in. And we mentioned Quebec took a bit of a delay with regards to the rest of Canada, but the rest of the world as well. And also we'll be talking about the proper implementation of BIM, what errors to avoid. CadMax works in 3D. It has been working this way for more than 10 years. Exclusively 3D. Our deliverables can be 3D or 2D, according to our customers' expectations. But we'll try to share our mistakes so you don't make the same mistakes. Then I'll talk to you about creating value. We'll be presenting 3 projects where we've used different processes in order to create upstream value in the design. Then the objectives of the meeting, well, there are 3 of them. One is to attract newbies towards a BIM implementation and then convince the skeptics. There's always a certain percentage who don't believe in the virtues of BIM, of these new technologies. And we'll tell you a few success stories and then share with the experts, of whom there are some here, share some hints, some tips that we've used on different projects. So our industry at a glance, some of the general characteristics of the construction industry in Quebec represents, about 9% of the Quebec GDP. So we're talking about $0.1 of dollars in Quebec fall in that category, in this industry. Most of the people here are in the non-residential industry, and that is the case. There are very few investments in R&D as opposed to other industries, pharmaceuticals, high technologies of other fields, and it's quite inferior. Very fragmented industry. 50-70% industries have fewer than 10 employees. On a project team, we may have many companies who participate on the same project. Now, the market structure, well, sometimes we don't stop and think about it so much, but the end user in this case is the owner of the building. He's the one who governs the final aspect of the building. Now, in manufacturing, we don't see that. We have like a push type. We have an idea of a product. We develop the product. We put it in the production. We sell the product. And the consumer can or can not use the product. It's his choice. In construction, it's the other way around. It's the owner who has the idea to build. He says, I want a very precise product. Well, that changes the way in which we'll follow the process. It's a very process with requiring a varied expertise. So it's very complex, both vertically, horizontally. I always draw a parallel with the manufacturing industry, where a company can decide to integrate vertically in the industry and to produce from A to Z. In construction, we don't really see that. I know of no company who has all the services, all the disciplines, all the trades incorporated. Often we see multidisciplinary and multi-company teams, and often without any contractual agreement in its present state. It gives us this kind of model. Okay, it circles a project, the 3 disciplines, 3 resources, 3 companies, different companies, and so the project is that much more complex. Now, within the market structure, we mentioned that the traditional structure is incompatible with collaboration and innovation. The design bid structure, build, is very different. We see in Quebec and in Canada, the lowest bidder usually wins out. So this is a big hindrance to development, to research, and there's a break between the design and the construction phase. There cannot be collaboration between the two normally, between the 2 teams. So there's a low rate of adopting things like BIM and integrated project delivery systems, PD. Now, there are a few things in here, a few reasons why we may have fallen behind. Small companies such as mine and many other companies in Quebec have an organizational structure that is very flat. They have little or no budget for R&D. Everything's always late and delayed, so we're always pushing back the idea of innovating, of moving forward with our ideas. And with the bigger companies, big firms, what we see is often they grow after mergers, and their headquarters are decentralized, one in Quebec, one in Montreal, one in Three Rivers. And there's a matrix structure by department and by project. So it's quite difficult to manage the implementation of a new technology, such as BIM. Now, under organizational structure still, there is a culture of innovation that is very difficult to implement. Why? Well, for the reasons that I've identified. Knowledge transfer that is difficult, not at the right time, always rush projects, and the project teams are slowly dismantled bit by bit till the end of the project. So you have a team that's acquired experience that normally should be an added value to the global knowledge of the company, but we remove resources one by one until the project is complete. There's never a time where we can say, okay, here we're going to stop and we're going to look at the history of the knowledge that was acquired and we crystallize it within our company. We see also a poor centralization of project information. So there's within companies information gathering of data that is not appropriate. There are many parallel systems. Every project manager will have his email, his way of managing his data, his projects, which means that it becomes very difficult to have a solution that is global to the company. So, result, old methods, overrun costs, general unsatisfaction. And meanwhile in China, and we've seen some very interesting projects, let me introduce a third one that I found a little quite striking.
So what you have just seen, those of you who have never seen this video, 360 hours this was in China. There's a lot of preparation work in factories, but throughout the world, companies cooperate in order to to get results that are quite great. So in 15 days for this project, we would have got at the permit getting stage. So we have a lot of work as an industry, as a people, to catch up. The fact that we're late and we're behind, and we become internationally competitive, and that. So now that we know the problem, how do we resolve the problem? Those of you who are new with the BIM, we're going to cut the apple in two. I like using two terms to define the BIM. There's the closed BIM and then the cooperative BIM. Before cooperating with others, before opening to the world, you have to know your technology and do BIM alone initially. This initial phase, that is to create a software and to refine it. And that we present ourselves as a firm that can deliver a good model, a good software model. And then you move on to the cooperative BIM, and you open up to the rest of the world to offer your services. For the implementation of the BIM, one thing you have to be aware of is that it's a disruptive innovation, as opposed to the CAD that involved new technologies, that is the use of computers to generate plans. Here the process has stayed the same. They haven't really changed, except that the tool that we use to reach the results have changed. That's CAD. But with BIM, all the processes are questioned. Some are put aside, some are used. We have to estimate the relevance of all of the processes, and those that are not relevant are put aside. Once this is done, then we can move on to using BIM. Purchasing the software. We talked of multi-platforms. We talked of not favoring one platform in particular. The danger of having one platform in particular, you see the Microsoft system, which is problematic. Because everybody has Microsoft, everyone has it, but it's not necessarily the best solution. So in deciding what solution to use, you have to really look at your own needs and make your decisions accordingly. Some software will remain number one for a long time, other software for just a few months. So your advice, look for interfacing capabilities, because the people you work with may not be working with the same software as you. So it has to be shared. Implementing the BIM, it involves a major change within the company, and this change should not be taken for granted. You can't think that people will simply accept a new way of working. There has to be change management. It starts with management. Management has to be convinced 100% that it's the right path to follow. It's the only way that you'll succeed in reaching a consensus with everyone that okay, it may not be perfect initially. It will be an iterative process. We'll have to go through by trial and error, but ultimately you'll deliver a superior product in the end, and you'll save time and money. Also approach people and have people understand that the BIM will not make them unemployed. So in taking such an approach that you don't threaten their jobs, then it'll be easier for everyone to become involved. But the software is not a turnkey operation. The software has to be adapted, has to be refined, and has to be harmonized with the business processes. So to think you're going to purchase a software and that 2 weeks later everything will be functional and will perform optimally, it can't be done that simply. It doesn't work that way. Implementation still, you have to find a champion, a BIM coordinator or a BIM manager. Their names, I like using the word champion. We require leadership, perseverance, and that is to be a pit bull. Many things will have to be redefined, standards, ways, processes. There'll be some internal crisis. So a pit bull is needed who has organizational skills, strong organizational skills, and that he can really implement. But the person also has to have technical capacities. There, often there's no answers, so decisions have to be made in order to implement the BIM. Very often you have to be able to go beyond, and you have to be sure you master your own technology. What I suggest, the champion should deal exclusively with the task of implementing the BIM. This was one of the success factors. If you don't have one dedicated person, one champion that is dedicated 100% to implementing BIM, the project shouldn't be implemented over a period of months and years. No, it should be fully implemented as quickly as possible, and you'll become competitive much quicker. Training, give basic training to everyone if possible, and have outside training, outside of the office. This is the best approach. People should leave the office and be totally focused on their training. It shouldn't be done in steps. Learning the so it's very important. There has to be process by process implementation. Often we hear of pilot projects. That's not necessarily bad, but it has to be a low-risk project where there's no hurry. So study a process, a situation that's process by process. So you have to analyze the most expensive processes. So one by one, integrate the processes, the most profitable ones using 3D, and continue to do the rest in the classical way. So people will soon realize when it is good to use the BIM. So it'll be one step at a time that will be mastered, and then we'll move on to the next phase. In the implementation, I spoke about it earlier, there are some old processes that can no longer exist at the time of the CAD. So there'll be processes that will disappear, and others will be developed. So the CAD standard can't be put aside altogether. So you have to get out of your usual CAD references and accept that you won't be doing things as you've always done in the past. 3D models, there's 10 ways to do each thing. There's many ways of doing the same thing. There may be 3 or 4 that are optimal, and you have to make decisions, and you have to be uniform. So all of the key steps have to be documented, and you have to get the consensus of your key people. There are 3 ways of doing things, for instance, but you have to choose one and then follow through with it. Once everyone is agreement, then it's documented, and the methodology becomes everyone's baby. Respecting the procedure becomes everybody's business. It's hard to reach this point, but it's well worth it once it's done. Maintenance, you have to be aggressive in development. So you have to continue to invest to make sure that the champion is still in control, constant follow-ups, see if there are new functionalities, new versions, are there things that are not working properly. You have to follow this closely. Certain processes may simply have to be put aside at some point. the development and the maintenance of the system has to be everyone's responsibility. That's how you'll get good results. It can't be the boss who's always complaining, and employees can't always be doing things differently. Also, teach your people about added production and train your personnel so that they can identify potential problems and know, for instance, when 10 minutes was wasted in waiting for the software to be ready, so that when there's a real problem that reoccurs, that you're ready to make the change. And so bring people to see these phases as being a source of waste, and train your people to avoid waste. All software, and they're not open source, but they can go beyond the accepted parameters. So that's the cooperative side of BIM. So you fully control your tools, you can deliver a high quality product. You have to open up to the world then, because Pareto has ruled 80-20. So you'll have to make the investments to improve your processes will no longer work. So you'll have to then continue on the BIM road. So how then to add value? You have to redefine deliverables and think out of the box. Once you master your processes, how can you deliver them better to the client? What software does my client use? What platform does my client use? What machines are used in his plant? How can I present the information to the client so that it be better in order to avoid redundancy? If I do an auditing, and if my client does the proper auditing or verification, and then an operation can be transformed to be more efficient, then we do it. So the right work at the right time by the right person. So it has to. So there's the execution plan. The BIM execution plan I've never seen per se. I've seen partnerships, one-on-one relations, and you develop them with people you trust. Do not necessarily wait for large-scale deployment, and make the most of what you have for the particular project you have. So a company decides to start using BIM without any contractual agreement to begin with, simply on the basis of good faith, and gradually you start developing the project until it becomes official or more formal. So we have to put aside our egos, so we have to keep the overall objective in mind. In other words, you have to become essential to the operation. An item we don't talk about often is the key is the eye from BIM. A 3D model is nothing else but a database with graphic output. Each discipline adds its own data set to the database to illustrate different concepts. You have to accept the fact that the data is not always readily usable, and so to say that the software does not allow us to do a certain process, what you have to ask yourself is what can the software do? Can we use the software? Can we enter it and leave it readily? What value does it add to our operations? Well, then it's okay. To be able to do this, to master the I in the BIM, there has to be, you have to hire a programmer and become independent. The clients become dependent on your firm, and this is to your advantage. And so, adding value, a few examples. Interfacing between 3D models and SQL database. So a homemade ERP where the data can be transformed. There can be a homemade ERP, and there's a project history directly in the model objects. The client wants to know why you did such and such a thing. All the information is available. You'll send such and such a document to at such a time, and this removes a big risk on our part as regards our liability. So we can go back and forth in both directions and to transform work or information into work and then into project history within the model. When the client calls, to be able to give him the reason for which things are done within 30 seconds. The client usually expects that you'll phone him up tomorrow and you're able to answer within 2 minutes. Then the client will be impressed. And when the client asks why, well, you explain that what you're doing, you're using the BIM model, and that's why you become so much more efficient. Another example of adding value is synchronizing design model with fabrication model. That is reusing geometry. Lots of energy was used to develop the most efficient geometry. So use them as much as possible. If the model was not sufficiently accurate, because the degree of accuracy varies from one discipline to another, there are some standards that have been developed throughout. So you have to be able to use existing models and enter them into a fabrication model and to return the information and to share the coordination attributes. There's temporal information, there's coordination information in these models, and if we can return it to the client so that the client may have it and become familiar with it, this is added value, and the client will profit from this. Delays are thereby reduced. During the design model, all the plans are finalized. The level of accuracy has to be acceptable. All the elements have to be there. Everything has to be coordinated. And we can move on to the next phase, which is that of construction or fabrication. Another example, approval of 3D approval of shop drawings. We were surprised by the results. The approval rate was 3 to 4 times faster. Often in their daily work, the part that they like least is to receive 2,000-3,000 drawings that have to be approved, and then they're just approved without thought, and it also allows engineers to better understand what we wanted to present. 2D is not 3D. We see the world in 3D. So if we are able to get approval in three dimension, then people understand much better. No license is required. The license is free. Each software company has its own platform. We developed our own. There are tools that already exist on the market that are free of charge to automatically integrate various software together. I'll zoom here so you'll understand better that there's a model on the right. The engineer does the approval. We'll see the engineering sketches. You can see the questions that were raised, the drawings that were made, and can see any geometric properties of the unit, and then can say if everything is okay, it can be approved. Changing the menus so that the results of his approval can be sent directly, or rather than receiving 1,000, 2,000, 3,000 approved models, I get a file that takes up about 1 meg, and it can be used electronically. So in a few minutes, I know I have 2,000 drawings, and 1,999 are approved, and on one of them there's a small mistake. Another example of adding value, we worked in a team that had a structure engineer, connection engineer, and a draftsman, drawer. So we worked simultaneously produced structural engineering, connection design, and steel detailing. We would receive models from microstations in FDNF format. We entered it into our software. We made sure that the geometry was accurate. At this phase, no plan had yet been made. There was the engineering connection. All our sketches were generated. They were every sketch was integrated, so we had every sketch was in 3D. And once this was approved, we could integrate the model directly. And so this is an example. We talked of a unique model earlier. The process here, structural engineer did their model in 3D. They passed the ball, and the structural plan was transferred. So there's a focus on giving very accurate 3D models, and would say what were the pitfalls, where to be careful. So when we receive a modified structure system, there's work, there are changes. We always want to abandon the structural model quickly to move on. So it's major work for the draftsman. But as long as we have a 3D model that comes from the same source, we can compare them systematically, so we're sure that we'll catch all of the changes that have been made. So there's a new deliverable that resulted, a hybrid, and a 3D model entirely coordinated, and it's ready for the construction phase. So the risks are reduced, and the contractor will then receive plans that are complete and a list of materials that will be needed, and will give the exact weight, the exact size. So people will sleep better if they know that all of the modeling and the plans and the information is complete. Adding value, design assist, consulting contract with key construction specialists during design phase. Subcontractors and the contractor, all of them have their own expertise. CanBIM has experience in construction. Another company is able to quickly detect dimensions that are lacking from a plan. So even if they don't get ultimately get the contract, they'll still have improved their processes, and they will have been exposed to the critical approach of the contractor. If the owner wants to pull the plug, so to speak, after the design phase, because he doesn't have financing or for whatever reason, there still has been contacts that have been established with the subcontractors. So the general contractor will be sure that the design was reviewed by all components, all players in the field, and they can be sure that the appropriate material has been used. I talked about 3 projects earlier. There's a Mosaic Potash Colonsay expansion project. We used integrated services. Throughout the project, there was an interface between the 3D model, the Edmonton International Airport Marriott Courtyard. There was also synchronization of the structural and design phases. These came from microstations, so there was joint work between structural engineers and structural engineers. So the Marriott project, the structural work was done through Ribbit. So there was a synchronization of models. There was an interface between the 3D models and the database. And there was a design assist. It's not us who did the design assist. It was a designer from Western Canada who was at the table very early in the process to make sure that everything was optimized and that the results were remarkable. University of Alberta, there was a synchronization of the 3D models, a complete approval of 3D designs. I'll come back to this. Often we have to manage incomplete information, and we're still asked to provide drawings that are incomplete. So this work to generate a design that's not used. If the concept changes, then the drawing is lost. So by having this model, we would not generate the workshop design, but only the models that involve the questions that were really relevant at the moment. So this project was very good for us and for the client. And then one morning, we were able to approve a substantial part of the plan. There were architects around the table. They started with a given model, and on a large screen, they were able to go from one assembly to the other. So the engineering firms developed a certain type of expertise in 3D because they were able to receive the deliverables in the new form, and they accepted this deliverable, and they found it very performant.
And then finally, the interface between the 3D model and the database we use that on all our projects. And in conclusion, you need to understand your industry. You need to simulate the BIM. You've got to become good within your own environment and to collaborate upstream and eventually to become master of information. Gentlemen, start your engine.